5.6, analyzing logarithmic functions. So we're going to solve for y, and y equals log base b to the power of x. Not to the power of, but of x. So let's just change it into an exponent. So if I have b to the power of y, I have x. And if I'm solving for y, I'm going to take the log of both sides. So I have log of by to the power of y equals log x. I can bring that exponent in front, so I have y log b equals log x. And if I want to get y by itself, I can divide by log base of b. So this is a way we can evaluate in our calculators logarithms of different functions by doing log of x and divided by log of b. So for here we have log base 5 of 50, so we're going to go log of x, so log of 50 divided by log of the base, which is log of 5. And you can type this into your calculator and you get 2.430. So it is very easy to type in different logs into your calculator. So this one would be log of 6 divided by log of 8, and you get 0.8616. So that will become useful for you when you're trying to do things, and now you don't have to convert and all that stuff. Okay, we're going to sketch some logarithms. So we've already done this. You should know that undefined for -1 and 0 for all of them. Okay, what you should know is if your value in front of the logarithm is positive, it will be increasing. So this one will be increasing, this one will be increasing. This one has a negative in front, so it is decreasing. And this one is decreasing. And because it has not been translated in any way, we know we have a point at 1 and 0. They will all have an x-intercept, and they will all have a point at C, comma A. So for the first one, it is 10 and 1. There's a 1 in front of this. The next one will be 10 and 2, 10 and -3, and 8 and 1. What I know about my negative, or my 0.5 here, is that it's going to be a negative number. It goes small and then it's getting bigger because it is increasing. And because it's decreasing, we know that these are going to be positive numbers, and then it's going to get, oops, the last one's increasing too. Why did I put decreasing? Only one's decreasing. So to graph it, very easy, 1 and 0, and C, comma A, so 10 and 1, and then whoop, and actually go through the point, unlike what I just did. Alright, so our domain is x is greater than 0, and our range is y is an element of the real numbers. Next one, 1 and 0, and 10 and 2, and then there you go. 1 and 0, and 10 and -3, and then connect. Lovely. Graphing is so hard sometimes. And 1 and 0, and 8 and 1. And you are done. And what you should also notice is that the domain and the range is the same for all of these. So it should be very easy for you to graph a very basic function with just a C value and a base. We can also apply the transformations like we have been doing with every other unit. So our transform function will be y minus k equals c log base a of d x minus h. And all of those variables are the things that have been happening the whole time. So our c value is going to stretch it up and down. Our d value is going to stretch it left and right. Our h value moves it left and right, and our k value moves it up and down. and we can make the same manipulated point like we have been doing. So for our first example, we have log base 3 of x and y equals log base 3 of 2x plus 6. So we're going to graph them both. So very easy for log base 3 of x. We know we have a point at 1 and 0 and 3 and 1. And we also know we have an asymptote at x equals 0. Okay, so it would be a point at 1 and 3 and 1. So there is my graph. Okay, for our log, what is it? Log base 3 of 2x plus 6. So first of all, we're going to have to rewrite this. So log base 3, and we're going to take a 2 out, so 2x plus 3. So we're going to figure out what our values are. So our d value is going to be 2, and our h value is going to be negative 3. Our c value is 1, and our k value is 0. So we're not doing anything to the y values, but our x values will be changed by a factor of 1 over 2, so x divided by 2, and then we are subtracting 3 from it. So our new points will be 1 divided by 2 is a half, subtract 3 is negative 2.5, and 0. 3 divided by 2 is 1 half, minus 3 is negative 1 half, so negative 1 half and 1. And 0 divided by 2 is 0, subtract 3, moves our asymptote to negative 3. So let's plug the draw the asymptote in first. Love me a good asymptote. We have negative 2.5 and 0. And we have negative 1.5 and 1. So our new transformed function will be like this. Actually, be more like that. Okay, we can find the y-intercept exactly. So if we want to find the y-intercept, we're going to plug in a 0 for x. So we have log base 3 of 2 times 0 plus 6, which is log base 3 of 6. So we'd go log of 6 divided by log of 3, and our y-intercept is at 1.63. So that's why I moved it down, because it was a little bit too high. Alright, so our domain and range for this function is x such that x has to be greater than negative 3, because we moved our asymptote, and our range doesn't change. It's still everything. Alright, so that's how you graph logarithms. So let's graph log base 2 of x and log base 2 of 2x minus 1. So I have we have a point at 1 and 0 and 2 and 1 and an intercept at 0. Okay, so we'll plot that at 1 and 0 and 2 and 1, and there is my graph. Okay, so we have log base 2 of 2x minus 1. We need to take out a 2, so it'll be 2x minus 1 half. So we'll make our new point. We have our c value, our d value, and our h value, and our c value, and our k value. Our d value is 2, and our h value is 1 half. Our c value is 1, and our k value is 0. So once again, y is not changing. And our x value is going to be divided by 2, and then we're going to add a half. Alright, just kidding. I read this whole question wrong. So because there's no bracket after the 2, this negative 1 over here is the same as our k value. So we could rewrite it over here. So it could be y plus 1 equals log base 2 of 2x. So unless there's a brackets around this, then that's actually your k value. So our h value is 0, and our k value is negative 1. So we're going to do y subtract 1. So we have 1 divided by a half is a half, and 0 subtract 1 is negative 1. 2 divided by a half is 1, and 1 subtract 1 is 0. And x, 0 divided by 2 is still 0. So our asymptote is still the y-axis. We have a point at 0.5 and negative 1, and we have a point at 1 and 0. So this graph is going to look like that. So our domain and our range don't change. So x is greater than 0, and our y is an element of the real numbers. So be careful, because obviously I was just not careful. For this one, log base 2 of 2x minus 1. Because there is no brackets here, it's the same as saying brackets around just that. So this is our k value. Let's do 2 more examples. Same thing. So let's graph log base 5 of x. So our points that we're going to graph are 1 and 0 and 5 and 1, and our asymptote is at 0. So we have 1 and 5 and 1. So here is our graph. Alright, now our transform point. So we have y equals negative 1/2 log base 5 of 2x plus 2. So because that is in brackets, it is our h value. And we need to simplify that to say 2x plus 1. Okay, so we have our d, our h, our c, and our k. Our d value is 2, and our h value is negative 1. Our c value is negative 1/2, and our k value is 0. So our point is going to change by going from x to x divided by 2 subtract 1, and our y value is going to be negative y divided by 2. So if I plug this into or I transform my points, they are going to become negative 0.5 and 0, and 1.5 and negative 0.5. And our asymptote is going to move to negative 1. So there's our asymptote. We have a negative 0.5 and 0, and we have a 1.5 and negative 0.5. So this one is getting reflected down. And it would look like this. We can find our y-intercept exactly, so let's do that. So we're going to plug in a 0 for x. So we have y equals negative 1/2 log base 5 of 2 times 0 plus 2. So it's negative 1/2 log base 5 of 2. So we're going to type in negative 0.5 times log base 2 divided by log base 5. And the number that you should get is negative 0.215. So that seems pretty good for our picture. Our domain for this function is going to be greater than negative 1. And our range is everything. Alright, last example, log base 2 of x. Let's do that first. So we have a 1 and a 0, a 2 and a 1, and our asymptote is at 0. So we got 1 and 0, and we got 2 and 1. So here's our log base 2 of x. You should be getting pretty proficient at graphing those. Okay, and looking at, we've got all sorts of transformations, we got everything. So 2 log base 2 of negative 1/3. This is supposed to, whatever, x plus 1 plus 2. That plus 2 is actually supposed to be outside like that. Alright, so we have D, H, C, K. Our D value is negative 1/3. Our H value is negative 1. Our C value is 2. And our K value is 2. Whenever K is on this side of the equation, you don't have to switch the sign. Because if we were to move it to the other side of the equation, it would be negative 2, and then we'd know it's plus. So whenever the K is over here, just leave it like that. So our new point is going to be negative 3 times x, because we're dividing by 1/3, and then we're subtracting 1, and 2y plus 2. So pause the video, and I want you to transform the points and the asymptotes. You should have gotten negative 4 and 2, negative 7 and 4, and our new asymptote is at negative 1. Because it's on this side of the equation, I know I'm going to be able to find my y-intercept, so let's find it. Just kidding, it's on the other side of the asymptote. We can find the x-intercept. It's not that important. Yes, it is. Okay, 0 equals 2 log base 2 of negative 1/3 x plus 1 plus 2. So first thing we're going to do is we're going to minus 2 to the other side. Then what we're going to do is we're going to divide by 2 to get rid of this c. So this is gone, and this turns into negative 1. Now we're going to change it to an exponent. So 2 to the power of 1 is equal to negative 1/3 x plus 1. And now we're going to just solve for x. So we're going to, this should be a negative 1. Multiply both sides by 3, because that will cancel this. And we should make it a negative 3 to get rid of that. So we have 2 to the power of negative 1 is 1/2. Times that by negative 3, we get negative 1.5 equals x plus 1. And we'll subtract 1 from both sides. So negative 2.5 is equal to our x-intercept. So I'm going to plot my point at negative 2.5. We also have negative 4 and 2. And we have negative 7 and negative 4. I don't have room for that, so it's just going to go like that. So our domain is x is going to be less than, not equal to, negative 1. And our range is going to be all the real numbers. So you can also find your x-intercepts if necessary, if they have been translated. Alright, and that is all.